What is a metric space in advanced mathematics? Imagine you are trying to measure the distance between 2 points in a city. You might walk, drive, or fly. Each method gives you a different way to think about how far apart things are. In advanced mathematics, we use a similar idea called a metric space. It is a way to understand and measure distances in many different settings, not just in a straight line or on a map. A metric space is made up of 2 main parts. First, there is a set of elements, which can be points, numbers, or even functions. Second, there is a special function called a metric. This function takes any 2 elements from the set and gives back a number that tells us how far apart they are. Think of the metric as a rule that assigns a distance to every pair of points in the set. Now, this rule has to follow some important properties. The first is non-negativity, and the idea that only the same points have 0 distance between them. So, the distance from a point to itself is 0, but between different points, it is always a positive number. The second property is symmetry. This means that the distance from point A to point B is the same as from point B to point A. The last property is called the triangle inequality. It says that if you go from point A to point C, the direct distance should never be longer than going from A to B and then B to C. This makes sense because taking a longer route should not make your trip shorter. In coordinate geometry, we often use the distance formula to find the distance between 2 points in a plane. The formula is the square root of the difference in the x-coordinate squared plus the difference in the y-coordinate squared. This formula is a perfect example of a metric because it satisfies all the properties we just talked about. It turns the set of all points in a plane into a metric space. But metric spaces are not limited to points in space. They can include many other things. For example, the set of all continuous functions on an interval can be turned into a metric space by defining the distance as the maximum difference between the functions over that interval. This shows how flexible and powerful the idea of a metric space is. It helps mathematicians measure and compare things in many different contexts, whether they are geometric shapes, functions, or even more abstract objects. Understanding what a metric space is helps us see how distances work in a broad sense. It is a foundation for many areas in advanced mathematics, like analysis and topology. It allows us to think about how objects relate to each other in terms of distance, no matter what kind of objects they are. So, in simple terms, a metric space is a set of elements with a rule that measures how far apart any 2 of them are, following rules that make it behave like our usual idea of distance in everyday life.